सौरभ भाई स्लॉट बुक किए क्या?
Hello everyone, how are you all?
Fine sir, how are you?
I'm also fine, thanks for asking. बाकी बाकी लोग कैसे हो आप सब? यार किसी की आवाज नहीं आ रही, क्या बात है? 10 ही आदमी हो अभी तो। अच्छा,
बढ़िया है सर।
एक कंप्लेन आया है कि आप में से कोई होमवर्क सबमिट नहीं करता। क्या प्रॉब्लम, मतलब क्या बात है? व्हाट इज द इशू? कुछ प्रॉब्लम आ रहा है, समथिंग लाइक दैट? हेलो, कुछ तो बताओ भाई। कुछ प्रॉब्लम आ रहा है, नहीं कर पा रहे हो, क्या इश्यूज है? होमवर्क सबमिट क्यों नहीं करते? मतलब आप में से जो भी यहाँ पे हो सब होमवर्क सबमिट करते हो टाइम पे, इज इट?
यस सर।
तुम्हारा तो मालूम है, तुम जुनैद सौरभ वगैरह करते हो, बाकी so all of you here, whoever are present right now, submitting the homeworks, is it? भाई कुछ तो बता दो। प्राइवेटली टेक्स्ट पे तो मैसेज कर दो, करते हो या नहीं करते? सब कोई करते हो इधर पे? देखो, मैटर है, घबराना नहीं। क्वेश्चन अभी टफ लगेगा, ये धीरे धीरे सबसे हो जाएगा। नो नीड टू थिंक ऑफ, यू आर जस्ट न्यू टू ऑल ऑफ दिस टॉपिक्स। फाइन, ट्राई टू अंडरस्टैंड हाउ टू अप्रोच द प्रॉब्लम। कोड उसके बाद करो, हाउ टू अप्रोच द प्रॉब्लम, ट्राई टू अंडरस्टैंड दैट फर्स्ट। दिस इज व्हाट द फर्स्ट रिक्वायरमेंट। इसीलिए मैं तुमको तरीका बताता हूँ प्रॉब्लम सॉल्विंग करने का, थिंकिंग का डायरेक्शंस देता हूँ, ठीक है? कि किस लॉजिक के बेसिस पे सोचना है। मैं डायरेक्ट नहीं बोलता कि ऐसा है और वैसा है, ठीक है? ट्राई टू अंडरस्टैंड हाउ टू अप्रोच द प्रॉब्लम फर्स्ट, देन गो फॉर द कोडिंग पार्ट। ओके, and these topics are new. All of you will definitely get these things. Practice more. Why you have to submit the your homeworks regularly is that this is a must for you. And moreover, at the end, for the placements, whichever company will be coming, they will be seeing how much regular you were, how much submissions you have made. So that will be a factor for you at the end of the placements, right? So please don't miss out the homeworks. I have got the report that many of you don't are not submitting the homeworks right now. Okay. Who are not submitting, you can privately text me. No at all, no issues at all. And why is it so? क्या प्रॉब्लम हो रहा है, दिक्कत आ रही है? Tell me your issues so that something can be done about it. What is the issues? So only for how many days you haven't submitted the homework? Is it recently 4 or 5 days, or it has been continuous for months? What is the issue? एक दो की बात नहीं है, कंटिन्यूअसली कौन नहीं दे रहे? ठीक है, okay, do submit your CCs. This is required, and don't get demotivated. You are seeing most of the topics for the first time. ठीक है, yes, it will happen. लेक्चर के मुकाबले कभी कभी सीसी के क्वेश्चंस काफी एडवांस ऐसा होगा. लेक्चर है ना, लेक्चर में मैं सिंपल एग्जांपल्स दिखाना जरूरी है ताकि तुम समझो टॉपिक में हो क्या रहा है. स्टार्टिंग में मैं अगर 2 लेवल अप जाके दिखाने लगूं तो प्रॉब्लम हो जाएगा. होता है ना, ड्राई रन में समझने में देर लगता है ना, जब मैं ड्राई रन करता हूँ प्रोग्राम्स. इट इज नॉट द केस दैट आई विल बी ड्राई रनिंग. It is the case that once I dry run, it's your duty that dry run on your own and understand how the program is working. मैं तो कुछ देर के लिए आता हूँ क्लास में तुम लोग के साथ, राइट? कितना? हार्डली 2 hours. Fine. It's not the case that how much I am dry running. It's the case that after I dry run, have you practiced it on your own or not? This does matter. लाख लेक्चर देख लो, इससे कुछ नहीं होगा, इतना मैं भी बोल देता हूँ. Once you do it on your own, this is required. Fine, please submit, because it is a must for you, and it is very important for your placements too at the end, whatever will be conducted, right? You can tell me, open up your issues, that what issue else you are facing. Perhaps you will get. अच्छा, एग्जाम के कितने दिन बाद रिजल्ट आता है? सबका हो गया इवैल्यूएशन?
यस सर.
कल है ना? कल है कि कितनों का है कल? कैसा हुआ?
आज लास्ट था सर.
आप लोग के इवैल्यूएशन कैसे हुए?
सर अच्छा था.
चलो, क्या क्या पूछा?
सर कुछ नहीं, बस वही टेस्ट के क्वेश्चन पूछे थे.
चलो, बढ़िया बढ़िया. ओके,
सर आज का टॉपिक क्या है?
ऑपरेटिंग सिस्टम 3 लास्ट टॉपिक है आज. ऑपरेटिंग सिस्टम. ओके, so before starting, we will take some look at, okay, how many types of memory are there. Types. Type 1, hard disks or hard drives. Who does not have hard disks in your computers? Can you run without hard disks? Can anybody run their computers without a hard disk?
No sir.
Okay, next is your RAM. Okay. Third category comes cache memory. Fourth category comes out to be CPU registers. So see, not everything, all the processes, okay, every data you want to keep in your computers, you can keep it in your hard disks. they have the largest size. They have the largest size or largest memory inside your computer is present inside your hard disk. As compared to hard disk, how much hard disk do you have in your computers?
1 TB.
1 TB, right? Somebody has 1 TB. Junaid has 1 TB of hard disk. The largest amount of memory that you can have for your computers is using that will be provided to you by the hard disks. Okay. Okay, now how much RAM do you have in your computers?
8.
8 GB, is it? So somehow the hard disk as compared to the hard disk size of the RAM is 10 times lesser. Am I correct? Size of the RAM is at approximately 10 times lesser as compared to the hard disk. Correct or wrong? Approximately. Let's compare. Let's say that. Okay, yeah. Let's say that this is not 8. This is 10 GB. Let's say. What is the size of 1 TB?
1024 GB.
Exactly, 1024 GB, or that is, okay, yeah, somewhere I have faulted. You can assume that hard disk is of size 1000 GB approximately. Okay, hard disk can be of size 1000 GB and RAM is present inside your computers 100 times lesser. 100 times lesser is the value of your RAM. Okay. Now, what about cache? Anybody knows about cache? Have seen that? Okay, some term called cache is associated with your computers.
Yes, sir.
टेम्पररी मेमोरी जो बोलते हैं.
अच्छा, पहले बताओ कितनों ने कैश के बारे में सुना है, कितनों ने नहीं सुना, पहले बताओ.
सर सुना हो मैंने.
Okay, let's see here inside my computer. Let's see whether in the properties do we have any mentioning of cache or not. Cache memory नहीं है ना इधर, नहीं है. Okay, see, RAM that has been given is 4 GB. Yeah, that's all. No information is given about the what is the size of the hard disk. Okay. So yeah, cache का information चलो यहाँ पे है नहीं. But usually, as far as I am remembering, the cache memory that I have, yeah, sure, Kanu, share करो. शेयर करो. कैश दिख सकता है?
यहाँ है सर, देखिए.
कैश इज 2.5 GB. कैश तुम्हारा इतना प्रेजेंट है? वाह यार.
इसमें स्वैप भी रखे हैं, यूज अभी तक हुआ नहीं.
Okay, yeah, you can close
Stop
it.
setting, sir.
Yeah. यूजुअली ये जो डेटा दिख रहा है ये मे बी लिटिल बिट इनकरेक्ट है इतना, या फिर यस, बिकॉज कैश मेमोरी शुडंट बी दिस. इतना तो मैंने भी रेंज कभी देखा नहीं है कि भाई कैश मेमोरी इतना हो गया.
नहीं सर, हो सकता है उतना यूटिलाइज हुआ करके दिखा रहा है.
नहीं,
मैं भी श्योर नहीं हूँ.
कैश में
वो मैक्स टू मैक्स ऐसा 10 MB ऐसा कुछ होता
या
है.
मैक्स टू मैक्स 10 MB होता है. मैक्स 8 MB में भी हो सकता है. ठीक है, मैं जो लार्जेस्ट साइज देख रहा हूँ कैश MB का 256 KB it starts and 8 MB you can say that okay that is the maximum cache that may be possible in your computers as of now. आसपास ही है. Okay. So as far as I am remembering, my present laptop has 3 MB of cache present. Okay. 3 MB of cache present. 3 MB of cache present. So as compared to RAM, cache is how much times smaller? This is 10 GB. Let's suppose somebody's computer has 1000 GB of hard disk, 10 GB of RAM, and 3 MB of cache. So as compared to the RAM, let's say, as compared to the RAM, what is the size of my cache?
That's 3,300 and ऐसा कुछ होगा.
अच्छा 10 GB, 1 GB कितना MB होता है पहले बताओ.
1024 MB.
Okay, so it is approximately 10 into 1000 MB. You can assume. Okay. So let's say that, okay, let's not take it for simplicity. Let's keep that my cache is 1 MB. Cache is 1 MB. So I can say that, okay, as compared to RAM, the cache is 10,000 times smaller. Cache memory is 10,000 times smaller. As compared to RAM, the cache memory is 10,000 times smaller. And similarly, registers are way less. Registers store way less memory as compared to cache also. Okay, let's see, though they are comparable, but yeah. How much size our computer registers has? Yeah, so see, these registers hold very small amount of data, 32 bits to 64 bit. So again, that's a very 64 bits in size. Maximum it can have 64 bit of size. That's the lowest unit possible inside our computers, bits. And 64 bits can be the size of CPU registers, maximum. You can assume. Rarely it will be more than 64 bits, okay? Rarely it will be more than 64 bits. So see, it is way more memory that we can assume that this is in bits, some bits. Let's say maximum is 64. So what you can observe from here? Hard disk has the largest memory possible. And as we go down the line, the memory decreases. Is it? Memory capacity decreases. Is it? Is my observation correct?
Yes, sir.
Sure. Okay, now let's come to some other factors called speed. Okay, called speed. As we go down the line, let's not go down the line now. As we go up from the bottom to the upper part, the speed of these memories increases. Sorry, speed decreases now.
सर फिर SSD मेमोरी किस में आता है?
क्या?
SSD जो बोलते हैं एक्सटर्नल.
ठीक है, वो हार्ड डिस्क कैटेगरी में ही आ रहा है. ठीक है, SSD जो मेमोरी मानते हो वो सब हार्ड ड्राइव्स होते हैं मेनली. So we say that if you go from top to bottom, the memory capacity decreases, but if we go from bottom to up, the speed decreases. Getting the point? Getting the point? Or if we say, let's write down the points. From top to the bottom, what happens? First, capacity, storing capacity. What happens to the storing capacity? It decreases, right? Next, from top to the bottom, speed decreases. Speed of the memory decreases. And again, if I go from top to the bottom, the cost of these memories increases. Okay, yeah, let's not write like this. Speed doesn't decrease from top to bottom. My mistake. Speed increases. The more faster a device is, more will be its cost. Okay, two factors. Hard disk is the slowest memory available to us. Main memory is faster as compared to hard disks. Cache memory is more faster as compared to RAM. Registers, again, you can assume registers are again more faster as compared to cache memory. Fine. Is this point clear? These points are clear to all of you?
Yes, sir.
So these are some of the points that I wanted to discuss. Okay. And if I go from top to bottom, capacity of storing decreases, speed increases, and cost also increases. More faster a device is, more will be its cost. That's what the rule is. Understood, everyone? Please tell me.
Yes, sir.
Sure.
Yes, sir.
Let's go ahead. Let's go ahead. So what we discussed yesterday, process. Inside a process, whatever code it has, whatever code or data it has is divided into what? Can anybody tell me? Inside a process, whatever data or code it has is divided into what? कुछ तो बताओ यार. Is divided into pages. Is divided into pages. Okay. Something called pages. Fine. So now see what happens. For a process to execute, what happens is that computer inside RAM, the memory is limited. Inside RAM, the memory is limited. This is what the RAM, my RAM is. Memory is limited. So, okay, for executing a process, what it divides the process into components called pages. Fine, called pages. Now these pages, let's say my operating system tells me that, okay, I want to execute component now first. So your page 1 is required. So what will be happening? Page 1 will be required. It will be loaded into the RAM. It will be loaded into the RAM. Fine. Again, let's suppose it wants to, after component 1, it is in requirement of component 3, that after component 1, as per the user wants to execute component 3. So I require page 3. So what it will do? It will load page 3 into the RAM. Okay. As per the requirement, pages are getting loaded into the RAM for execution, and part by part, my process is getting executed. Fine. This is how your process is getting divided into pages, and as per the requirement is getting loaded into the RAM. Fine. So doesn't matter what is whether your memory is fixed or not. If sufficient amount of memory is available to me, if suppose this was the hole that was made, any other process, let's say T6 was getting executed here, and it has occupied this amount of memory. This hole was created. Fine. But yeah, this page for executing the current process that has arrived, this page can be fit into the hole. So this page can be loaded by the operating system into the hole, and part 1 of my current process can be executed. Fine. So this dividing the entire process into pages and loading the pages into the RAM as per the requirement, this is called demand paging. Fine. Fine. Now suppose there are total of 5 pages. There are total of 5 pages into my, that constitutes the entire process. And there were 4 divisions. There were 4 divisions into inside my RAM. So let's say inside division 1, okay, inside division 1 my page 1 is there. Into the second slot or the second partition, page 2 is there. Third partition, page 3 is there. Fourth partition, page 4 is there. Let's say now my entire memory is filled up. Entire memory is filled up by either the pages or some other process as well. Fine. And now computer, the operating system has been commanded by the user that, okay, process, the component 5 of the process should be executed now. Operating system has come into the requirement that, okay, component 5 of the process now should be executed to complete the process. But here see, none of the memory is being free for loading this component. What shall be done? Any idea? For loading the page 5, the last page, let's say this is the last component, corresponds to the last component of my process. For completing this process, already my page 1, page 2, page 3, page 4 are inside the RAM, and RAM is completely filled up by task 6, page 1, page 2, page 3, and page 4, completely filled up. But for to complete the process, I want to execute page 5. And operating system has got the command that, okay, now page 5 should be executed. What will happen? Any idea?
सर स्टक हो जाएगा.
स्टक तो होता नहीं है ना, कभी देखा है एक प्रोसेस के लिए दूसरा प्रोसेस होता रहता
टेम्पररी
है.
मेमोरी बन जाएगी एक.
ऐसा कौन सी टेम्पररी मेमोरी बनेगी, क्या लगता है? So see, is that have you hard disk?
प्रोग्राम एरर आ जाए.
नहीं ऐसा कभी नहीं होता. Have you hard disk? How many of you have hard disks? How many of you have hard disks inside your computers? So some part of the hard disk is reserved for such process. Reserved, okay, and it acts. Its acting is as such. It is part of the RAM. Okay, but actually this memory is inside your hard disks. Now what will am I audible?
Yes, sir.
Yes, sir.
All of you can hear me?
Yes, sir.
अरे यार पता नहीं इंटरनेट डिस्टर्ब कर रहा है आज. Can see my screen, everyone?
Yes, sir.
बताओ जुनैद क्या हुआ?
नहीं सर, आप पूछे थे ना किसके साथ ड्राइव किया।
क्या हुआ?
आप पूछते ना किसके साथ ड्राइव, इसलिए हैंड रेस किया था।
ओके, वॉइस इज कमिंग क्लियर? From my end, today internet is very badly disturbing. Able to see my screen, everyone?
Yes, sir. It's visible.
So my voice is coming clear to all of you?
Something lagging, sir. Your voice is lagging, sir.
Hello? It's still lagging, right?
Yes, sir.
दिक्कत हो गया यार, इधर पे नेटवर्क बहुत बुरा आ रहा है. Just give me 2-3 minutes to check. Fine. Hello, am I audible?
Yes, sir.
यस सर।
अब सही आ रहा है?
Yes, sir. Clear है.
चलो सही करते हैं अब. Screen visible? Screen is visible?
Yes, sir.
Yes, sir. It's visible.
Okay, fine. Let's begin. So what happens is that suppose that a scenario has arrived when the page 5 should be loaded for process completion. Okay, but no memory is left. It may happen because RAM is limited and very less in memory, right? So what happens is that some part of your hard disk is reserved. Okay, reserved for your such operations. Fine. That okay, this is reserved to keep a tally with the RAM. To keep a tally with the RAM. Fine. It acts as if this reserved memory is a part of RAM, but actually this memory is a part of your hard disk. So we call such memory virtual memory. We call this virtual memory. Now what will happen? What do you think? What should happen? Some part of the memory should be what? Should be cleaned up, right? So that I can accommodate my page 5. Is it or not? Some part of the memory should be cleaned up. Let's say this some page of T6, task T6 was been executed. This is no longer required. Or it may be again processed sometime later. So what will happen is that operating system will take out this T6 again. T6 will take out this page of task T6 from the RAM. It will insert page 5, okay, into the hole, okay. And let's say this T6 will be transferred here, will be kept into the reserve. That okay, whenever required, we will keep you back. We will keep you back into, we will again track you back into the RAM. So this process of keeping an extra memory for enhancing the RAM is called virtual memory. And this process removal, this page of another process removal and keeping and inserting page of another process, okay, P5, this is called page eviction. Page eviction means one page that is present inside your RAM will be removed. And inside that, another page of any other random process will be inserted as per the requirement. Fine. 2 pages have been swapped. Now, actually, yeah, we don't interact with the computer, doesn't interact with the RAM itself. This is not the case. Because if operating system interacts directly with the RAM, okay, if it interacts directly with the RAM, speed of RAM is very slow. Neither operating system directly interacts with the RAM or with the hard disks. It is not possible because as compared to hard disks and RAM, both processors are very fast. Let's say processors are 100 times faster. So processors has to wait till the time operating system is interacting with RAM and hard disks. Okay, processor has processed the entire processes present inside it and is waiting. So we have to minimize this waiting time and we have to do something. So what happens is that to interact with the process faster, we introduce the cache memory. To interact with the processor faster, we introduce something called cache memory. Okay, now see what happens. This is the cache. This is the cache, very small in nature. Okay, this is the cache. Now what will happen? Cache is in connection with the RAM. Cache is in connection with the RAM and RAM is further in connection with the hard disk. RAM is in further connection with the hard disk. Operating system does what? So let's suppose inside the processor, I require a page. Let's say page, any random page P1 I require for any process T. For any task T, page P1 of it is required for being executed. Operating system does what? Will try to find out, and this page is not present into the processor. Okay, it should be inserted, not present at all. So what will happen? Operating system first check with the cache memory. Is it present inside you? Cache. If it is present, operating system will directly fetch it from the cache. From the cache, operating system will fetch it and put it into the processor. This makes the process faster. Cache is 10 times, at least 10 times more faster than RAM. So interaction with the processor with this cache is more faster. Fine. Processor has to wait lesser if operating system searches the cache for any page P1, okay, then the wait time for the processor will be minimized. If suppose inside the cache it is not present, operating system will check into the RAM. Is it present here? Is it present here? If it is not, if it is present here, then it will be grabbed from the RAM and will be put into the processor. If it is still not present here, then operating system will go to the last choice. Is it where it is present inside the hard disks? Okay. If it is, if this entire thing is not even present inside the hard disks also, it will raise an error that, okay, this entire data is not present inside the computer. Perhaps this data has been given wrong by the user. Okay. So to interact with the processor faster, we introduce some lower level of memory called cache memory. Okay. Cache memory. And this is at least 10 times faster as compared to RAM. If inside the first operating system, suppose it requires page P1 for executing any process T. Fine. If first operating system will search into the cache, whether this page is present inside the cache or not. If it is, it will be fetching that page from the cache and we will be putting it into the processor. If it is not present inside the cache, operating system will search it into the RAM. Okay. And at last, the last choice is the hard disks. If inside the hard disks also there is no page as such is present, it will raise an error that, okay, either your file, see whether you have deleted your such files or not. Something like that will happen. Fine. This point is clear to all of you. Please tell me that. Why we require cache for making the process faster?
क्लियर है सर.
आपका सबको?
Yes, sir. Clear है.
Now see, this process of searching into the cache, operating system searches for a page into the cache. If it finds it, this is called cache hit. And if it misses here, if it misses to find the page into the cache memory, this is, if it misses, then it is called cache miss. क्रिकेट खेला है ना सबने? कैच हिट हो गया, कैच मिस हो गया. That's all. These two terms should be kept in the mind. Okay.
सर हम लोग के लिए क्या वो कैचेस अच्छी हैं कि बुरी, मतलब?
अच्छे हैं, बहुत अच्छे हैं, बहुत इंपॉर्टेंट चीज है, नहीं तो तुम्हारा कंप्यूटर बहुत स्लो हो जाएगा. Many of the time you have thought, right? Many of the time you see that you wanted to start a process, you wanted to open a browser, let's say, but it is waiting. This browser, for opening the browser, it is taking some time. Why this is happening? Because for the required pages or the required components of the process that we want to execute right now, it is not present into the cache. Then operating system searches that for inside the RAM, whether inside the RAM also that process is present or not, or pages pages required are present inside the RAM also or not. If inside the RAM also it doesn't finds, it searches into the hard disks. So that is the entire process, and it becomes a very late process. If it goes up to fetching the entire data from the hard disk, it becomes very late process. Okay, so that's why cache memory is very necessary. We have right now, I guess, level 1, level 2, level 3, and level 4. 4 levels of cache is been given into your computer. Okay, this level 1 is faster than level 2, level 2 is faster than level 3, level 3 is faster than level 4. 4 levels of cache memory is being provided. This is what the recent I know. Okay. Fine. Is it clear to all of you? Firstly, tell me that.
Yes, sir.
सबको क्लियर है ये बात?
Yes, sir.
Okay, so what we have seen, what do you mean by virtual memory? Some part of reserved memory into the hard disk. What happens? Any task T6, some pages of task T6 occupies some memory, right? It is not required by the operating system as of now. So this part can be freed and put into the reserved memory called virtual memory. And then some pages of my current process can be kept, can be brought back into the RAM, okay, for execution. So this is how my this is how the virtual memory works. Okay, some part of reserved memory of our hard disks. But to make the process faster, we should not rely much on RAM, but we should have something called cache also. Why? Because so that operating system can search the pages faster. That's why we keep cache. Okay. And this process of taking out a page is called, from the current memory, is called what? Page eviction. Okay. Two pages have been swapped. One page is brought back to the virtual memory and another page that was required is put to the RAM. This page is called, this particular thing is called page eviction. Okay. Now, based upon what technique the page eviction is being done? What? So there are two kind of things. Okay. Don't think that this is not the case with RAM. So right now we have brought this feature. This feature is also present inside the RAM also. Okay. That firstly, if any page is not present into the cache, okay, that will be from the RAM, that will be brought into the cache, so that in future, if I require this page again, I will be able to grab that from the cache and the entire process will be much faster. So earlier we used to rely on RAM only, but right now what we see is that no, the process, let's say any page P was not inside my cache. So whenever operating system searches for it into the cache, it finds that, okay, right now it is not here. What we will do, if we find it into the RAM, we will put this page into the cache also. We'll put that page into the cache so that in future, if it is again required, our entire process execution will be much faster. So this particular see, the operating system, if it is unable to find any page into the RAM, or more precisely right now into the cache, both you can say RAM or cache, into the memory as a whole, if the operating system is not able to find the page that we are currently looking for, this entire phenomenon is called a page fault. That, okay, this particular page is not present into my current memory that I'm looking at, I have to find it somewhere else. This particular phenomenon is called page fault. Getting the point? So let's say this was my cache. What we said, this is my RAM, this is my cache. Cache is too limited, right? As compared to RAM, cache is again very much limited. So entire cache is also filled up. Fine. So again, to bring something from RAM into the cache, I have to free some of the memory of RAM, right? I have to free some memory of the RAM also to bring any page P from RAM to the cache. I have to free some memory of the cache also to bring any required page P from the RAM to the cache. Okay, so what techniques do operating system looks for, that how can we bring any particular page from RAM to the cache? One such technique is called least recently used. And these two techniques are there. Okay, least frequently used and least recently used. These two techniques are being used by operating system to bring any page that is not present into the cache. Okay, and when it will be required, we will come to the scenario. Okay, when suppose an entire cache is filled up, no more free space is there, and I have to bring some page P into the cache for making the process faster. Any of the process I can utilize to free up some space into the cache and bring some required pages inside it. Okay, so see what happens. Least recently used, and if any cache works on this technique, this is the most important, so we will be discussing this. Okay, if any cache memory works on least recently used technique, that is called LRU cache. Okay, so what happens here? So let's say these are the sequence of pages for me I require. This is the sequence of pages I require, my operating system requires to execute a process. These are the sequence for executing a process. Okay, let's say my operating system is required, and initially my cache is empty. Fine. Okay, fine. So tell me, is page 7 present into the cache? Is it true? Is page 7 present into the cache? Is it true? Cache is empty, right? Nothing is present inside it. So this 7, if the operating system requires 7, it will look into the cache. Cache is empty right now. 7, I require page 7. The operating system will look into the cache and it is empty. It will find that, okay, this entire cache is empty. So, okay, so since I have searched for a page, haven't found it into the cache, it raises a page fault. That, okay, for searching 7 into the cache, a page fault is occurring. I have to see it somewhere else. Okay, fine. One page fault already occurred for page 7. Now let's keep it into the cache. Kept it into the cache. Fine. And let's say this cache cannot hold more than 4 pages. Fine. Let's come to the next page. I require, after executing for page 7, I am in requirement of page 4. So what will happen? Can anybody tell me? Operating system will search where? First, it will search where?
Cache.
It will search into the cache, right?
Yes, sir.
Any page 4 is present into the cache? Any page 4 is present into the cache? No, right? So it is since into the memory cache, page is not present, it is giving me a page fault. Page fault is there. So, okay, let's bring 4 into the cache. Fine. Let's bring 4 into the cache. And okay, let's execute whatever is the requirement, whatever is written into page 4. Fine. Now let's come here. Now operating systems comes for page 0. Anything present into the cache, it will first search into the cache. Any page 0 is present into the cache?
No, sir.
No, sir.
Okay, so page fault, right? Page fault. Okay, now bring page 0 into the cache. Fine. Now again, operating system will search for page 9. Is it present into the cache?
No, sir.
Okay, let's that. Then again, we can say for page 9 also there is a page fault. So let's bring 9 into the cache. Fine. Brought. Now what will happen? Entire cache is filled up. Am I correct? Entire cache is filled up. See. So now operating system is in requirement of page 1. Which one? Some cache has to be removed, right? Some cache memory slot has to be removed so that I can bring page 1 into the cache. Tell me, what shall I do? Least recently used. The least recently used page I have to remove from the cache. Which one is the least recently used?
7.
7 was the first, right? 7 was the first page that came into the cache. This is the least recently used, not used recently. So let's remove this 7 from the cache and let's bring removed 7 from the cache. And since I am in requirement of page 1, let's bring page 1 into the cache. Done. Page 1 arrived. Now see, operating system now after page 1, it is in requirement of page 4. What will happen? Operating system will search this
Inside
page
cache.
4. Will search for this page 4. Where?
Inside cache.
Inside the cache. Is page 4 present already?
Yes, sir.
Yes.
Okay.
Yes,
So
sir.
no page fault, right? Now page fault does not occur because I have found the page into the cache memory. Now let's come to next. Operating system will search for page 6. Operating system searches for page 6. What will happen? It will
Page
search
fault.
for page fault. Why? Because 6 is not present into the cache, right? Page 6 is not present into the cache. So what will happen? Which page will be removed from the cache?
0.
Because 4 was recently used, right? 4 I have just queried. It was present into the cache. So 1 has been just before 4, 9 just before 1, 0 is the least recently used page I have. So let's remove this and bring page 6 into the cache. Done. Now it will again. So this 6 also gives me a page fault because that was earlier not present into the cache. Again, it will search for page 4. Is page 4 present into the cache already?
Yes, sir.
So what will happen? No page fault will occur, right? Operating system can directly grab this from the cache itself and give it to where? The processor for executing.
सर जो सेकंड टाइम जो 4 आया है
हाँ,
उस टाइम पे भी पेज फॉल्ट होगा ना, क्योंकि उस टाइम पे भी था नहीं
नहीं
कैश के
था,
अंदर 4.
था 4 था.
सर 7409 था ना उस टाइम पे.
हाँ,
74091.
7409 है, फिर 7 हट के 1 आया, 7 को हटा के 1 आया, राइट? तो 4 तो
सर.
ऑलरेडी था, ठीक है
हाँ.
ना? तो पेज फॉल्ट नहीं. पहले क्या
नहीं
था
सर,
कैश के अंदर?
जब 6 को सर्च कर रहे थे
7409 यही था ना कैश के अंदर पहले. फिर 1 आ रहा है, पेज 1 विल कमिंग, सो 7 हटेगा ना सबसे पहले और 1 आ जाएगा, राइट? 1 आ जाएगा. नेक्स्ट 1 के बाद क्या आ रहा है? 4 आ रहा है, तो ऑलरेडी कैश में प्रेजेंट है ना? सेकेंड टाइम जब 4 आ रहा है तो 4 तो ऑलरेडी कैश में प्रेजेंट है, तो नो पेज फॉल्ट. पेज इज ऑलरेडी प्रेजेंट इन द कैश. सो क्या हो रहा है? 4 अब मोस्ट रिसेंट बन जा रहा है, मोस्ट रिसेंट. फिर क्या होगा? 6 आएगा, 6 आएगा, 6 आने के बाद क्या होगा? 6 is not present in the cache, 0 will be removed, most least recent 0, 6 will be inserted into the cache. Now next, again 4 will be coming, already present. So what will be happening? 4 will be directly grabbed from here and it will be given to the processor. So 4 becomes the most recent page into the cache. Clear to all of you how LRU cache works? How LRU cache
Yes,
works?
sir.
All of you?
Yes, sir.
Sure?
Yes, sir.
किसी को कोड करने का एक असाइनमेंट मिला हुआ था ना, LRU कैश कैसे बनता है?
सर अभी रिसेंटली दिए थे.
ओके, क्या 5 मिनट रुक जाए, ब्रेक लें या पढ़ाते रहें? बताओ.
नहीं सर, एक एमसीक्यू
सही है, चलो लेट्स
ब्रेक
टेक
भी
एन
हो
एमसीक्यू.
जाएगा.
एक्चुअली आज मैं भी थोड़ा टायर्ड हूँ. let's take first MCQ. Yeah. Given the first MCQ, take another MCQ also.
सर एमसीक्यू किधर दिए? सेशन सेक्शन में?
सेशन में, हाँ. Given 2 MCQs.
सर अभी 2 ही एमसीक्यू है ना?
अभी 2, फिर बाद में करते हैं क्लास खत्म होने के बाद.
ओके
सर नेटवर्किंग वाला स्टार्ट कर देंगे.
देखता हूँ 2 टॉपिक और बाकी है तुम्हारे ऑपरेटिंग सिस्टम का. देखता हूँ टाइम मिलता है या नहीं नेटवर्किंग. बट नेटवर्किंग ज्यादा कुछ है नहीं नेटवर्किंग में. ठीक है.
नहीं तो सर थोड़ा ज़्यादा टाइम कर देंगे. आधा
ये
घंटे में हो जाएगा.
लगता नहीं है मेरे को. ठीक है, देखता हूँ. चलो स्टार्ट करते हैं फिर से. So second question has been given to you 100%, right? एकदम 100 सबने सही किया. Eladio cache removes the least recently used page. This is true, right? True for everyone. Is my screen visible to all of you?
Yes, sir.
Now see one thing. How our operating system actually works. You write a code, isn't it? Let's say I have written a Python code. I have written a Python code. So how does the execution of Python code happens? How does the execution of Python code happens? Who will tell? Is it line by line? From the first line, the execution will start and come down to the last line. Something like that happens. How many of you agree with me here? If I say that, okay, execution of any Python program that I have written till now starts from the first line, ends in the last line. Is it? Is it? Is it the case? All of you agree with me? 2 persons are agreeing with me here. Rest, what about the rest? 3 persons.
Yes, sir.
So see, okay, this is not the case in real life for everything. Okay, this is not the case in real life for everything. A process is fairly large. A process has fairly large code. Okay. This process for being executed has to execute larger code, very large code. Small programs that we write, for that it will work. It will give you result in 1 second, no problem. But for bigger processes, this is not the case. हो ही नहीं सकता कि तुम लाइन बाय लाइन एग्जीक्यूट करोगे और तुम्हारा एग्जाम मतलब प्रोसेस तुम्हें जस्ट 1-2 सेकंड के अंदर रिजल्ट दे देगा. ऐसा नहीं होता. This is not the case. What happens is that your entire process is broken into parts. Entire process is broken into components, let's say. Fine. These components are called threads. Basic building blocks of process. Process inside process is called a thread. Okay. Don't confuse this with pages. Pages are logical components using which operating system breaks down your code and keeps on executing as per the requirements. Fine. In actual process, in actual scenario, this process is being broken down into smaller components called threads. Now your operating system has cores, right? Not operating system, your processor, is it? Your processor has separate cores, right? These cores are responsible. These cores are, let's say, I have a dual core. 2 cores are present inside this is my entire processor. 2 cores, C1 and C2, are there inside my processor. Fine. This is the nature of dual core. Now a process has arrived for getting executed. Fine. What will happen? This process will be, let's say it has 2 threads, T1 and T2, and let's say T3. This process has entire codes. Let's say this code is corresponding to first few lines of the code, let's corresponds to T1. Next few lines corresponds to T2. Next few lines corresponds to T3. These are how your threads look like for a process. Now these individual threads can be carried out at individual cores. Individual processor is same, but their separate cores can handle separate threads. Fine. These threads, this is an entire process. This thread are building blocks of your process and are executed by different cores of your process. And this is called concurrent. This is called not exactly concurrency, but concurrent nature of executing process. That various different parts of your same process are being executed by the processor at different cores. Which parts? The threads part. Okay, your processor has separate cores, so my present process can be broken down into several parts called threads, right? And these threads can be handed over to separate cores of my process to run concurrently. Okay, to run concurrently. There is thread 1, thread 2, and thread 3. These are basic building blocks of my process. Okay, what is the difference between what you can assume is that, let's suppose thread T1 and thread T2 may reside in page 1 of the current process. Okay, page 1 is for deciding the memory. Okay, and T1, T2 decides what component, what code is residing into T1, what code is residing into T2. What is the component breakup? That will be decided by threads. And P1, how much So what should be the partition as compared to memory? Okay, so that will be residing inside a page, and inside that page there may be many threads. So what I can do is that I can load a page into the memory and hand it over to the processor. That processor will be having several cores, and those cores will be, let's say T1 and T2 is the number of threads inside my page P1. So these two threads of my process can be handed over to the processor to be executed into core C1 and C2. Getting the point? Okay, this does what? So now what happens is that, let's say inside my processor, there are 3 cores, and inside core C1, C2, C3, thread 1, thread 2, and thread 3 are being executed. Okay, are being executed. Fine. So what will happen is that its result is executed separately. Independently, thread 1's result will be coming. Independently, thread 2's result will be coming. Independently, thread 3's, the last component's result will be coming. And what will happen? They will be merged together. They will be merged together to calculate the final result. So if separate components are running parallelly, this does what? Give rise to concurrency, concurrent nature of a process. That okay? Rather than going line by line, let's break our program into several components, give it to the core of our processor, and that will take care of what? Executing each of the threads separately. So what will happen? The result I should get from each core will be coming much faster. The result I should get from each component will be coming parallelly. They are parallelly executing, right? T1, T2, and T3. So result expected from them, rather than going line by line, will be going parallelly. We will be able to fetch them parallelly. And after getting the result, let's say, after getting the result, I can merge them. I can merge them into a single result R and can give it to the user. This is how in real scenario your processing happens in codes. Okay, this gives rise to concurrency, concurrent nature of your process. And since it is concurrent, that okay, particular process may have several threads, and those threads can be separately executed. What happens is that time of execution becomes smaller. Time of execution becomes much faster, okay, as compared to if we have gone line by line. Getting the point? Why threads are necessary, and what is the difference between thread and a page, threading and a page? Getting those points?
सर एक बार और थ्रेडिंग एंड पेज वो अंडरस्टैंड करा दीजिए.
देखो, पेज का मतलब है एक मेमोरी ब्रेकअप. ठीक है, मेमोरी ब्रेकअप. प्रोसेस में लेट से प्रोसेस टोटल 4 MB का प्रोसेस है. ठीक है, तो लेट से 4 पेजेस बनेंगी, उसकी 4 पेजेस बनेंगी. ठीक है, 4 पेजेस बनेंगी, ईच ऑफ 1 MB. ठीक है, तो मेमोरी के लिए, मेमोरी मैनेजमेंट के लिए हम पेजेस के हिसाब से सोचते हैं. लॉजिकली वी थिंक दैट ओके, दिस प्रोसेस हैज 4 पेजेस. फाइन. whenever will be required, I will be, operating system will be grabbing the required page. Fine. Now see, inside a page there can be several threads of the process. Let's say thread 1 and 2 inside page 1. Thread 1 and 2 is there. Inside page 2, thread 3 and 4 is there. Inside page 3, 5 and 6, these threads are there. Fine. So individual thread may lie in any of the page. Fine. And these threads will be ultimately be executed at the processor. Okay. At the processor, these threads will be parallelly as well as independently executed. Getting the point? Make sense or not? These are very deeper things that I am going right now and should be given to you. Clear or not? Tell me that first.
Clear, sir. Thank you.
All of you? All of you?
सर थ्रेड को भी ऐसा बोल सकते ना, स्मॉल पार्ट ऑफ पेज?
नहीं नहीं, बिल्कुल नहीं, थ्रेड को बोलेंगे बिल्डिंग ब्लॉक्स ऑफ ए प्रोसेस। बिल्डिंग ब्लॉक्स ऑफ ए प्रोसेस, पेज मेमोरी के टर्म्स में बोलते हैं। मेमोरी कैसे डिवाइड हो रही है पूरे प्रोसेस की, उसमें पेजेस का बात लाते हैं। पार्ट ऑफ पेज नहीं है वो, पार्ट ऑफ प्रोसेस है। ठीक है, प्रोसेस किससे बिल्डअप है? थ्रेड से बिल्डअप है। ठीक है, पेज तो है चलो एक लॉजिकल इमेजिनेशन दैट हाउ ऑपरेटिंग सिस्टम विल बी फेचिंग द प्रोसेस। प्रोसेस की कौन सी पार्ट ऑपरेटिंग सिस्टम रैम में लाएगी, उसके लिए पेजेस का यूटिलाइजेशन है। फाइन, बट एक्चुअली में ऑपरेटिंग सिस्टम किस चीज से बना हुआ है, दैट इज वी ग्रैब थ्रू थ्रेड्स, एंड दीज थ्रेड्स अल्टीमेटली पैरेलल एग्जीक्यूशन करती है प्रोसेसर के अंदर। ठीक है, और कहां पर? कोर्स के अंदर। तुम्हारे जो कोर्स है उसके अंदर इंडिविजुअल थ्रेड्स एग्जीक्यूट होती है। पैरेलली हम सारे थ्रेड्स का रिजल्ट निकालते हैं और उसको मर्ज कर देते हैं एक जगह पे, ताकि तुम्हारा जो लेट्स सपोज कोई टैब खोल रहे हो, उसको जो रिजल्ट है तुरंत मिल जाए, मच फास्टर प्रोसेस हो जाए। फाइन, कभी पेज का पार्ट नहीं बोलना, वो मेमोरी के टर्म्स में आएगा। ठीक है, एंड दिस अ प्रोसेस कैन हैव मल्टीपल थ्रेड्स, राइट? मल्टीपल थ्रेड्स, दिस इज कॉल्ड मल्टी थ्रेडिंग। Process can have multiple threads. This is called multiple threading, multi-threading. ठीक है, any doubt? Any doubt?
No, sir.
No, sir.
Sure. Shall I move ahead? Two more topics are there of operating system. We'll finish it today only. See, okay, one thing. Several times what happens is that this is process P1, this is process P1, this is process P2. Process P1 and process P2, fine. Okay, let's say this process P2 is a person, responds to a person who wants to check what is its, person wants to check bank balance. Bank balance, fine. Bank balance. This process P1 corresponds to bank itself, who wants to update. Let's say this person P2 person has received salary from his company, so bank has been informed of that okay, salary is coming. Bank wants to update the bank details. Is it the bank details? The bank details. Okay, now tell me, will they have anything in common? Process P1 and P2, will they have anything in common? What should be common in between? Will the bank account be common for both of them for doing the task? Is bank account common for both of them? Tell me that, okay, if person has to check his bank account's balance, it will go to the ATM and execute some process, let's name it P2, and P2 will be responsible for fetching the current balance of the bank. True or false? And
True, sir.
if bank wants to update what is the balance, current balance of the bank, it will do what? It will perform some transaction, internal transaction related to bank. That transaction will be updating this bank account's details. Is it true that now we can say this bank account is common for both the processes? Is it? Bank
Yes,
account
sir.
is common for both the processes. This bank account is called a resource. What is it called? Resource for process P1 and P2. Getting the point? Bank account is called a resource for process P1 and P2. Okay. Using this resource, this process P1 and P2 will be executed. P1 has to do some task, right? It will require the bank account. It will require the bank account. Okay, let's name it R as the resource. P2, process P2 has to be executed. It will be requiring the bank account, right? That bank account, the requirement of both the processes, what you require to execute, both of them require the bank account. That bank account is called the resource. Okay, you give command, right, to the computer. I want to print. With a printer, I want to print. So printing is the entire process, correct? Printing is a process. For executing the print, a process P wants to execute printing. For executing this printing, it has to get some resource called printer, right? With using what you will be executing? Using a printer. So for that process, resource is the printer. Okay, without printer, this printing cannot happen, correct or not? So if you are requiring any particular thing, that particular such as printer, that printer becomes the resource of the process. Getting the point? Getting the point?
Yes, sir.
Yes, sir.
Okay, now see.
Yes, sir.
Let's see. So for carrying out, let's say two process have the same resource to execute. Okay, two process for getting executed should utilize the same resource. Fine. So what will happen? So there are few rules that we have to follow. Few rules should be there. Few rules should be followed. If process P2 is what? Checking, right? Checking the bank balance. Process P2 is responsible for checking the bank balance. So this P2 we say is performing some reading operation. What it is performing? Reading operation. P1, it wants to update the bank. We say that, okay, it is performing writing operation. Okay. Over the resource, using the same resource, they are doing two different tasks. P1 performs writing operations. P2 performs reading operation. Now see one thing, there is a rule. If any of the process is reading any resource, while the time reading is going on, P2 should not write. Fine. If P1 is reading, P1 is currently fetching from the bank account R. What is the bank balance? At that moment, bank should not update the bank balance rule. Fine. Now let's suppose at a time process P2 is writing into the bank account. Process P2 is writing into the bank account and want to have updated that, okay, 1000 has been salary given to you for this month by your. So initially your salary, initially your bank balance was 0. Now 1000 has been added. While the time P2 was updating the bank account R, P1 should not read. While updation, after the updation, it can read, but while updation, while P2 is performing the transaction, P1 should not read. This is the rule of performing. This is the rule if any two processes should execute and have some resource in common. This is the rule. Okay. Make sense or not? Make sense? All of you understood this?
Yes, sir.
Yes, sir.
All of you? Such kind of problem is called a reader writer's problem. What is it called? A reader writer's problem. I think many things you are able to know using this operating system. How is it feeling? All clear till here? Please tell me. All clear? Whatever we have discussed till now, everything is clear to all of you?
Yes, sir.
सौरभ आज भी नहीं आया ना? Okay, so now see what will happen. So let's say these are two processes. They are two processes. P1 is what? The read process. Was P1 read or P1 write? Which one have we have used? P1 was write process, right? Write. Write is the process of P1. And P2 was what? The read process. Is it? The read process. Fine. How can we execute this? What do you think? What do you think? How do we execute that? Okay, we have something in common called the bank balance, right? Called the bank balance. This is a common. Let's say it is 0. How can I ensure that while P1 is writing, P2 should not read it? How can I ensure that? What do you think? Any idea? What should we do so that these two processes execute separately? And while reading, writing does not happen, and while writing, reading does not happen. What do you think? Any idea? Can anybody share? Think for 2-3 minutes. Tell me, what
सर
do you
रिपीट
think?
कर दीजिए सर.
ये P1 P2 दो प्रोसेस राइट और ये B मेरा बैंक अकाउंट है. B मेरा बैंक अकाउंट है. बैंक अकाउंट को जब अपडेट करूंगा राइट के थ्रू, P2 रीड नहीं होना चाहिए. P2 से रीड नहीं होना चाहिए. और मैं रीड जब करूंगा बैंक अकाउंट को, तब राइटिंग प्रोसेस नहीं होनी चाहिए. व्हाट शुड आई डू? How should we execute it? What do you think? Any idea are welcome. Let's keep a variable here s. Okay, s. Let's suppose I want to perform the write operation. Okay, I have entered here. Write operation I want to execute. So I will do what? I will utilize two other functions. One is wait. One is wait. Another is signal. Another is signal. Okay. So let's suppose process P1 has arrived. P1 has arrived. P1 has arrived to perform the write operation. P1 has arrived. So P1 will do what? It will using a variable m, let's say using a variable m, I will signal that, okay, if any P2 process P2 comes for reading, it has to wait. So let's execute. Let's call a function wait. It will do what? It will mark the value of s. It will convert the value of s to be 1. That, okay, whenever this wait will be called, value of s will be converted to 1. Fine. Next. Now, after marking the wait, that, okay, s has been converted to 1. After marking s, fine. After S has been marked, what will happen? S has been marked 1. Now nobody can read it. So I can just update B's value. And after that, I can signal that, okay, now change the value of S to be 0 using M again. Okay. This using M, let's say, okay, wait M, signal M. They take arguments M for executing themselves. Okay. And signal M will do what? It will convert the value of S to be 0. Fine. It will convert the value of S to be 0. Fine. Till the time, first for writing, what I have to do, first I have to mark wait. I have to call this function wait, that, okay, change this value of S to be 1. Change this value of S to be 1. Change this value of S to be 1. Now do what? Change this value of S to be 1. Now update the bank balance to increase it by 1000 and signal M that, okay, I have done. Now change the value of S again to 0. Fine. Now let's say reader comes. Reader has come. So it will wait while S is equal to 1. Till the time value of S was 1. What was value of S? If it is 1, then we have to wait, right? If value of S is 1, that means wait signal has been made. Wait signal has been made. Okay, while S equal to 1, just keep it as it is. This marks an infinite loop. Wait till the time writing process is going on. Wait till the time writing process is going on. Fine. Now do what? After this is over, let's say after this code is over, let's mark pass. Till the time S is equal to 1, just pass. Or let's not write anything. Yeah, just pass. That, okay, do nothing. Do nothing. Wait, rather. If S is 1, that means wait command has been given. Else, when S is now, let's suppose signal has been made from here, S is now has been converted to 0. What we can do is that, now if S is 0, we can say that, okay, now we can call the wait, that, okay, while I am reading, we can say that, okay, don't write anything. Don't write anything and let me read the bank balance, and after that let's signal that, okay, my bank balance has been read. I have got what my salary has came, and I will signal that, okay, now again change the value of S to 0. So what will happen? I will, while I am reading, I will wait till the time writing operation is going on. Right? Once the signal has been made, okay, the writing operation is over, I will now enter into the wait zone. I will say that, okay, till the time I am reading, do nothing, don't write anything. Okay. So I will just, to mark how the read process will be, we will be just printing the value of bank balance, and then we will signal that, okay, now my reading task is over. Just we can again turn the value of S to be 0. That will mark that, okay, no reading process is going on. If any other writing process comes, it can happen, right? So we should add here also that, okay, if suppose reading process is going on, I cannot write. So what we can do, we can say here, while S is 1, do nothing. Do nothing. Do nothing. Got the process, how the reading and writing will be happening? If suppose writer has arrived, anyone will come earlier, right? Anyone will come earlier. Let's say write process P1 has arrived at time 2 and process P2 has arrived at time 4. P2 is the read operation, P1 has arrived. So initially value of S is 0. So what will happen? While S equal to 1, this condition will become false, right? This condition, S is not equal to 1. So what will it do? It will call the wait with some variable M. It will call the wait function with some variable M. This wait will do what? Turn the value of s to be 1. It is 1. Fine. It is 1. Now let's say by the time it was updating, the value of b. Okay. By the time it has updated the value of b, my current time is already, I have started from 2. My currently after updation, my time is 5. Now the read operation has arrived. So read operation has arrived. So if read operation is parallelly executed, it will wait, right? At time 5, it will wait. Why? Because the value of s is 1. It will do nothing. It will keep on waiting. Fine. Now after updation is done, let's say at time equal to 6, what happens? It has signaled that, okay, my writing operation is done. Convert the value of s to 0. That, okay, now you can read. So what will happen? This condition becomes false. And I enter into the reading zone. I can read the value of b now. So what will happen? Wait m. I will. Now the reading process will command that, okay, change the value of s to 1. Till the time I'm reading, nobody can write anything. Okay. So what will happen? Print b. I have read. Let's say this is the reading operation. I will do print b. Let's say I am taking out the statement, bank statement from the ATM. What is my current balance? That balance inquiry part that we do. And at the end, after I am done, signal it 0 that, okay, now my reading part is over. If any further transaction happens, the write process can come and update my salary. That's all. Okay. So these are two processes and have utilized the same resource. So the reading writing shall not happen the same time. To maintain that, we have utilized two different functions, wait and signal. Fine. The s variable that we were constantly updating is called semaphore. What it is called? Semaphore. And the m variable, using what we were calling the wait and signal, this m is called mutex variable. Mutex means ensure using a variable m, mutex variable, we will ensure that both process P1 and P2 are mutually excluded from executing together. Mutual execution. Mutex means mutual execution. Mutual exclusion, sorry. P1 and P2 should not be performed together. That is what we mean by mutual exclusion. Tell me now what doubts you are having. Tell me now what doubts you are having regarding this.
सर आप राइट प्रोसेस में भी लिखे कि s इक्वल टू 1 तो डू नथिंग, और रीड प्रोसेस में भी सेम चीज लिखे, तो
हाँ, क्योंकि
कॉन्सेप्ट कहाँ यूज हुआ?
0 का तो इनिशियल कॉन्सेप्ट है ना, इनिशियल वैल्यू ऑफ s 0 है. ओके यू आर करेक्ट, राइट. सिग्नल का ना कॉन्सेप्ट, सिग्नल तो बहुत,
तो इसमें करेगा तो दोनों ही एग्जीक्यूट हो जाएगा ना एक साथ.
कौन सा? कोई एक पहले आना पड़ेगा ना. ऐसा तो नहीं दोनों सिमिलर साइट में कर रहा है, कुछ प्रायोरिटी फिर देना पड़ेगा. सपोज रीडर भी आता है, राइटर भी आता है, ऐसा नहीं कि दोनों है तो बहुत हार्डली, बहुत मतलब ये चांस है कि दोनों साथ में हो जाएगा. फिर मान लो कि कुछ एडमिनिस्ट्रेटिव पर्पस हो गया, चलो अभी तो राइटिंग चल रहा है, कोई क्वेरी नहीं कर सकता, वो अंदर की बातें हैं, उतना नहीं देखते. बट यस, तो अगर वैसा आता है तो कुछ एरर आ जाएगा, ठीक है. या फिर यूजर जो है, प्रोसेस P2 लेस प्रायोरिटी का प्रोसेस है, रीडिंग तो बाद में भी हो जाएगी, चलो क्या करते हैं पहले प्रोसेस P1 को एग्जीक्यूट करते हैं, कुछ प्रायोरिटी असाइन हो जाएगा प्रोसेस को, ठीक है. ठीक है. बट अगर प्रोसेस P1 एग्जीक्यूशन में है तो मैं कैसे इंश्योर करूं प्रोसेस P2 नहीं होगा? फॉर दैट वी यूटिलाइज समथिंग कॉल्ड सीमाफोर एंड म्यूटेक्स. एनी डाउट्स यू आर हैविंग?
No, sir.
All of you can understand this concept. Go through this once more, this semaphore and mutex part. This is what we call reader writer problem. Last topic. Let me discuss, वरना फिर नेटवर्किंग के दिन फालतू हो जाएगा, मतलब देर हो जाएगा फिर. इसको डिस्कस करते करते लास्ट टॉपिक इज व्हाट वी कॉल डेडलॉक. Okay, let's say I have a process P1. Okay, I have a process P1. It requires resource R1 to execute. It requires resource R1 to execute. Fine. And process P2 is there. Process P2 is there. It also requires resource R1 to be executed. Fine. Now what will happen is that if suppose process P1 is waiting for P2 to end, process P1 thinks that, okay, this resource will go to process P2 first, it will finish the execution, then only I can take resource R1. Okay? Process P1 thinks that. And again, in the same manner, process P2 also thinks that resource R1 will be taken by P1, it will let it finish execution, then only I will finish the execution. Fine. If such kind of scenario happened, this gives rise to something called a deadlock. Or yeah, let's come to more better scenario. Let's not go for one resource only. Fine. Let's not take this example. This is a quite a vague example. Fine. Why will such thing happen? Anyone would grab that. Fine. Process P1 is there. It is holding a resource R1. Fine. It is holding a resource R1. Process P1 has resource R1 and process P2 requires resource R1 for executing. Now what happens is that process P2 holds another resource R2 and R2 is being required by P1 for complete execution. Okay? Getting the point? P1 is a process, P2 is a process. P1 has resource R1, P2 has resource R2. Now for getting executed, P1 for executing requires R2 and P2 for executing requires R1. So but R2 is with P2, P1, R1 is with P1. So till the time P1 is having R1, P2 cannot have it. Till the time R2 is with P1, P2 cannot have it. So this is giving both of them, this is causing both of them to wait. P2 will wait till the time P1 releases R1 and P1 will wait till the time P2 releases R2. It has to be, right? Resources are common. Resources are one. Resources, only one resource is present, let's say, inside our computers. And process 1 for getting executed, it will require R2. Both R1 and R2. Similarly, P2 also requires R1 and R2. What had happened is that R1 is being allotted by the operating system. To P1, R2 has been allotted to P2. So both of them will wait indefinitely for each of them to finish, but ultimately that will not happen. So this is giving rise to something called deadlock. That okay, what had happened is that because of P1, P2 is waiting, and because of P2, P1 is waiting. This is called something called deadlock. Okay. This is sometimes we call a situation has arrived when because of another process that is holding some resource, a process is waiting. Okay. And similarly is the case with other process also. So what is happening is there is a circular wait is happening. Circular kind of nature has arrived that okay, because of P1, P2 will be waiting. Because of P2, P1 will be waiting. Circular wait kind of nature has arrived. Fine. This is the characteristic of deadlock. Tell me first, is it understandable what is happening inside a deadlock? Is it understandable what is happening inside a deadlock? Please tell me first. Please tell me that.
Sir, can you repeat one more time?
Yeah, what is happening? See, stay unmuted. P1 is there. It is holding a resource R1. Okay. And P2 is there. It is holding another resource R2. But P1 for executing the process P1, both the resources R1 and R2 is required. This R2 is with P2 and this R1 is having only one resources R1. Sorry, this P1 is having only one resource R1. R2 is with another process. Similarly, what is happening is that P2, there is process P2, it is having two, it requires two resources, R1 and R2. It has R2, but it requires R1. So P1 for getting finished, P1 to finish itself require two resources, right? And P2 again requires two resources. So without, if one is not finished, another cannot begin. Another cannot begin. And similarly, if P1 wants to begin, it has to wait for P1 to finish. If P1 wants to begin, it has to wait for P2 to finish. But that is not at all possible. Why? Because both of the process requires what? Two resources and have only one. Such kind of a circular wait kind of nature has arrived. See, this thing is called deadlock. That none of the process here in this case will be executing at all. Fine.
Yes, sir.
Okay. So let's see what are the conditions. What are the conditions for a deadlock to occur? What are the conditions? Let us quickly see that. Resources are non-shareable. First, these any of the resources R1 and R2 cannot be shared between any process, right? Resources are non-shareable. Non-shareable. Fine. Next, no process. Let's say this processor does what? Operating system used to do what? Allot some chunks, right? 5 nanosecond, let's say, for process P. And then it used to remove that, right? So let's say this feature is not available for the operating system. Okay, it cannot allot any specific time for the process. Fine. Let's say only for 5 nanoseconds only my process P2 will be running or P1 will be running. Then it should wait and then give chance to P2 to finish. But that will not happen. Let's say this feature is not available for operating system. So such kind of thing is called, if there is a fixed chunk, let's say any process P can be executed for 5 seconds only, and then it has to, then operating system will command that, okay, you wait, you halt for a while. Okay. This feature is called preemption. Preemption. Before getting finished, you have to halt yourself for some time. This feature is called preemption. So if this feature processes, if these processes are non-preemptible, then it gives rise to non-preemptible, then it gives rise to deadlock. Fine. What process can you tell me is not non-preemptible? Any process that comes to your mind that cannot be halted for a while? Operating system that is running always, that is also software, right? That cannot be stopped. So we can say that such kind of processes can never be preempted, right? It cannot be stopped because your entire computer will finish at that moment. Two more conditions: hold and wait. Hold and wait. Process P1 holding resource R1, process P2 holding resource R2. Fine. R2, both R1 and R2 is being required by process P1. And P2 also requires both the resources. Fine. But since both of them are holding one resources each and are waiting for each other to finish, this feature is called hold and wait. Hold and wait. Waiting for another resource to come. Okay. But that is with another process that depends upon process, let's say the same process that is waiting for it. So this feature is called hold and wait. Next, last, this circular wait kind of nature. Okay. If P1 is waiting for P2 to finish, P2 is also waiting for P1 to finish. Why? Because P1 has resource R1 and P2 has resource R2. So this gives rise to a feature called interdependency, circular weight kind of nature. If both, okay, these are the characteristics of a deadlock. These four must be there. These four must be there for a deadlock to occur. Okay. Any doubt? What are the conditions with deadlock? Any doubt, or can you understand? Okay, so yeah, with this, today our operating system is over. From next Monday, we will begin with operating system, and by Tuesday, I will try to start the system design part. So let's take the rest of the MCQs and we will wrap up today. I think much of the part has been covered today, and yesterday was mathematical parts were there which we covered. Yeah, given third MCQ, please attempt, all of you. Okay, given the last MCQ also, please attempt, all of you. We'll carry out our discussion on Monday with networking. Okay. Let me create the attendance. You have created the attendance, all of you, please mark whoever, and whoever does not have any doubt, you can leave.
Thank you, sir. Good night.
Thanks all of you. Good night. सौरभ नहीं आ रहे आज?
Hello.
Hello, yeah, बोलो.
No, sir. For next test, what is from where the test will conduct, sir? Means after dynamic programming, DSA part or
Which one? Which one? Which test?
next text will come.
Okay, so I think that will be informed to you by the teaching coordinator only. I don't have any idea. Means since the entire syllabus till DP has been covered, I too don't know. Again, the full syllabus may be there for the next exam. Okay, it may be there.
Good night, sir.
Yeah, good night, all of you. Good night. I'm ending it here, okay? Tomorrow, doubt class. Those who have any doubts can come. If possible, I will be discussing one DP problem tomorrow. Okay?
Okay, sir.